Hey everybody, welcome to 6A, Maxima and Minima, Completing the Square, Chapter 6.1. So, up to this point, we've learned how to factor, which was a big part of Chapter 5, where we converted from standard form to factored form. Now, in this chapter, we're going to be focused on converting from standard form to vertex form and what it means and its applications. So first off, graph the following using a table of values or Desmos. Okay. So what I'm going to do is, instead of graphing them here, I'm just going to open Desmos. Okay. And type these equations in. So y equals x squared plus 8x plus 5. Okay. So here are the x-intercepts, so let me just make sure it's plus 8x plus 5, yep, okay. Now, I'm also simultaneously going to graph the vertex form. So y equals 1x plus 4 squared minus 11. Okay. Now, evidently, the purpose of you sketching these two was to realize that they end up being the exact same graph. Okay. Now, if you do want to practice graphing, by all means, you can use a table of values. So, for example, in this case, you can use a table of values. So, x, y, and I could just plug in random points. So let's use, I don't know, -5, -3, -1, 1, 3, 5. Yeah, just random numbers. So if I sub in -5 into here, okay, that'll give me 25. 25 minus 40 is -15. -15 plus 5, -10. Okay. -5, negative -5, -10-ish. Okay. Now, I can continue to do that, and eventually I will create a graph that looks like that. Okay. Over here, I could do the same thing, but instead of using the table of values, what I could do instead is recognize that the vertex here is -4, -11. Okay. I could find that vertex. So let's label this -4. Let's label this -8. Let's label this 4, let's label this 8. And I'll do the same thing here. So let me just scroll down. Okay. So -4, -8, 4, and 8. Okay, so the vertex here is -4, -11. So this would be -12. So -8, -9, 10, 11. Okay, so here is a vertex. Now, using my 1, 3, 5 rule from previous chapters, we know that, sorry, I'm just changing the color of this. Let's change it to red. That my A value is 1, right? So typically it's 1, 3, 5, but I'm going to multiply it by my A value of 1 times 1 times 1 times 1. I know, it seems redundant, but it's just to remind you how I got 1, 3, 5. If this A was a 2, then it would be times 2 times 2 times 2. Okay, now let's go back down. So a vertex of -4, -11, and since my new pattern is still 1, 1, 3, 5, so I'll go 1 over, up 1, 1 over, up 1, 2, 3, 1 over, up 1, 2, 3, 4, 5. Okay, I do the same thing on the other side. 1 over, up 3, 1 over, up 5. And then I should be able to sketch this graph, or parabola I should say. Oh, that's a horrible looking parabola so far. That's close enough. Okay? And that parabola should resemble this one, -4, -11, and it comes up just before the 0, just before the 0. Okay? Now, again, the purpose of this chapter wasn't to graph. It was to realize that these two graphs, if I were to sketch them, they would be the exact same. The question is, how do I go from standard to vertex? And this is a process we call completing the square. Okay? So how do we go from here to here? Well, let's start. So step number 1, I'm going to write down the standard form. Plus 5. Okay? Now to convert this, what do I do? Well, I take a look at the first two terms. Okay? And I common factor the coefficients, and only the coefficients, okay? So, common factor coefficients of only the first two terms. Okay? Now, it's a 1 here, and it's an 8 here. Okay? So what number grows the greatest common factor in both 1 and 8? Well, isn't it just 1? Okay? So what am I left with in here? Just x squared plus 8x, and then I'm going to copy down the rest, plus 5. Now you're probably wondering, well, what's the point? It's not always going to be a 1. If that was a 2, we would have to common factor out a 2. Okay? Now what do I do? Well, I'm going to rewrite the equation, but I'm going to leave a bunch of space here, plus 5. Okay? And why am I going to leave a bunch of space? Well, this is step 1 of completing the square. What I'm going to do is find half of this coefficient. Okay, so half of that is going to be 4. Okay, then I'm going to square it and add it to the equation. So plus 4 squared. Okay, so step 2. Divide middle term by 2, then square it. Okay? Now, the problem with that is, and I will explain why we are doing this later on. Now, the problem with this is, can I just change an equation? No. So I can't just randomly add a number because I don't like the way it looks. So what I'm going to do is, since I added the 4 squared, I'm also going to subtract it. Okay? Again, it seems redundant, but I'll explain why that is later on. So since I've added 4 squared and subtracted 4 squared, have I technically changed the equation at all? No, I did not. I'm manipulating it. Okay. Now, what do I do next? Next, I'm going to bring this other 4 squared out. So what I'm going to do is multiply the 1 times the 4 squared to bring it out of the brackets. Okay, so 1 times 4 squared would give me -4 squared. Okay? Now I'm going to copy down the rest, so I still have a plus 5 there, and then copy down whatever was in the bracket. Well, what was in the bracket? X squared plus 8x plus 4 squared. I know it's 16, but I'm just going to leave it as 4 squared for now. Okay? Now, we're almost done. What was the purpose of doing this? So the purpose of doing this is, once I get to this point, I want to factor that. Okay? I want to factor that. Now, why do I want to factor that? Well, if I look at that, is that not a perfect square? What's the square root of 4 squared? Or if that was 16, what's the square root of 16? 4. What's the square root of 1? 1. What's 1 times 4? 2. Double 2 is 8. Okay? Now, if that made no sense, that's okay. It just probably means you forgot what a perfect square is. But that's okay. If I looked at what's in the bracket, I'm going to ask myself, well, how do I factor that? So I'm going to use a different color. Let's go with purple this time. I'm going to look at that, bring it out, and ask, okay, how do I factor that? X squared plus 8x plus 4 squared. Well, I need two numbers that will multiply to give me 16. Okay? But at the same time, two numbers that will add to give me 8. What are those two numbers? 4 and 4. 4 and 4. The exact same number, right? Which means the roots are, or the factors, sorry, are x plus 4 and x plus 4, right? Well, are they not the exact same? So if they're the exact same, that guarantees us that it's a perfect square. Which means, what goes in here? Well, isn't it just x plus 4 squared? Now, let's copy down the rest here. So I have negative 4 squared, which is negative 16. What's negative 16 plus 5? That's negative 11. And here I have it, the vertex form. And is that not the exact same? X plus 4 squared minus 11, x plus 4 squared minus 11. So the whole idea behind this is this. If you look at the standard form and the factored form, or sorry, the vertex form, you realize there's this little, let me just change it to purple, this little bit in here, right, which tells us what the x value of our vertex is. So I want to somehow get from here to here. But what I realize is x plus 4 squared just means x plus 4 times x plus 4. Which means if I can somehow manipulate the first two parts of this equation, I'm going to ignore the 5 and turn it into something like this, into a perfect square, so that when I factor it, I get the same factor twice, and that is exactly what I want. Okay, this will take some time to learn. Okay, so there are obviously quite a few examples in this worksheet, and I'm going to go through them right now. Okay. Find the maximum or minimum point of this equation. So, again, let's just go with red. Okay, so this equation is in standard form. So it's asking us to find the maximum or minimum point. What? Well, in order to find the maximum minimum point, max, minimum, we need the highest point or the lowest point of a parabola, which is otherwise known as the vertex. Well, how do I find the vertex? By completing the square. And that's exactly what I'm going to do. So, step one, as I said above, was to take a look at these first two terms and only common factor the coefficient. So 2 and 12 was the biggest number that can go into both, clearly a 2. So I'm just left with x squared plus 6x, close the bracket, and then plus 11. Okay? Now, I'm going to rewrite the exact same thing, except I am going to leave a bunch of space here, plus 11. Now, what do I fill that in with? Well, I fill that in with plus, what is 6 divided by 2? Divided by 2, that'll give me 3, right? So what goes in here? 3 squared minus 3 squared. Now, why am I adding and subtracting? Because I can't just change the equation. Okay, now what do I do? Well, first, I'm going to write this down, 2x2. Now, I want to free this last term. Okay, so I'm going to multiply these two together to get it out. Okay. So what is 2 times negative 9? Because negative 3 squared is 9, so negative 9 times 2 is negative 18. Okay, negative 18, so 2 times negative 9 is negative 18, plus 11. Okay, now I'm just going to copy down the rest of this So we got x squared plus 6x plus 9, or plus 3 squared. Okay. Now, what is this in vertex form? Well, because this is a perfect square, okay, I need two numbers that will multiply to give me negative, or two numbers that will multiply to give me 3 squared, which is 9, or add to give me 6. And what are those two numbers? 3 and 3. 3 plus 3. So it's just x plus 3 squared. Okay, because x plus 3 times x plus 3 will give me this. Negative 18 plus 11 will be, negative 7. And there you have it. Okay? So, what is the maximum or minimum point? So the maximum or minimum point would be right there. So the vertex would be negative 3, negative 7. And because this is positive, that means it's opening up. So the a value, the 2 is positive. Therefore, minimum point is negative 3, negative 7. Okay? Alright, let's keep going. And of course, you can stop this video anytime if you think you get it. But what I'm going to start doing is completing the entire worksheet for you. Okay? Alright, the path of a ball is modeled by this equation. So we're going to have y equals negative x squared plus 2x plus 3. Where x is the horizontal distance in meters from a fence and y is the height in meters above the ground. A. What is the maximum height of the ball? I see the word maximum. Maximum should make me think of a vertex. In order to find the vertex, I need it in vertex form. In order to get it to vertex form, I need to complete the square. Okay, so step number 1. First two terms, factor out the coefficient, okay, which in this case is negative 1 and 2. Yes, so I'm going to factor out, the most I can get is factor out a negative 1. Okay, so by factoring out a negative 1, what am I left with? X squared, and what's 2 divided by negative 1? Which is negative 2x. And I'm going to leave a bunch of space right away, plus 3. Okay? Now, if you notice there's no number here, except you assume it's a positive 1, you've done it correctly. If you end up with any other number but a positive 1 here, that means you did not fully factor this leading coefficient. Okay. So now I have to find a number to add and subtract. Well, what's half of 2? Half of 2 is just 1. Yeah, what's 1 squared? Well, it's just 1. But I'm going to put plus 1 squared anyway, minus 1 squared. Okay. Now next step, negative 1. So I know what's going to need to go in here. So I'm going to copy all this. Maybe I'll use a different color. And copy all this down to get x squared minus 2x plus 1 squared. Close that bracket. Now, I don't know why I changed colors like that. That's annoying. Sorry about that. Anyway, so I still know that there is still this negative 1 that's there, right? So I need to multiply that with this term in order to free it from the bracket, to bring it out. So negative 1 times negative 1 squared. Well, negative 1 squared is just negative 1, not positive 1, because remember, negative 1 squared means negative 1 times 1. Okay? If there's a bracket around this, then it would be positive. But anyway, so that's negative 1 times negative 1 to give me plus 1. Okay? Then I still have the plus 3. Okay, and last step, -1. Now I need two numbers that will multiply to give me 1, +1, equals 1, or 1 squared I should say, which is 1, and two numbers that will add to give me -2, and those two numbers are going to be -1 times -1 is +1, -1 plus -1 is -2, so I would have x minus 1 squared, and then 1 plus 3 is 4, plus 4. Okay, so what is the maximum height of the ball? So therefore, and at what horizontal distance does it occur? So I know my vertex is +1, 4. So therefore, max height is at 4 meters. Yep, 4 meters, and it occurs at a horizontal distance. So this is a 1 of 1 meter. Okay, and part B is just asking us to do a quick little sketch. So part B, this was part A. Sketch a graph while indicating key points to represent the path of the ball. A sketch, not a full graph. So I know the vertex is at 1, 4. Okay. Ooh, that's horrible. 1, 4. So 1, 4 is about there, let's say. Okay. So I know that it's going to be going down. Okay. So while indicating key points. Now, I wasn't asked to factor in this case, so I don't know what the x-intercepts are. Okay. But I do know that there's a vertex, and I do know that the y-intercept is at 3. So I know the y-intercept is at 3 because it's in standard form. So that's all I know. So that means my graph is going to look, my parabola is going to look something like that, assuming that this is the vertex. Okay? Alright. Alex runs a business that charges $12 per snowboard and averages 36 rentals a day. She discovers that for every 50 cents decrease in price, her business rents out 2 additional snowboards. At what price can she maximize her revenue? So, we know that right now she charges $12. Okay? And she is averaging 36 rentals. So she discovers that every time she decreases the price, by 50 cents, she rents out 2 additional snowboards. So decreasing, but she gains 2 additional snowboards. Okay? So the question is, what is the variable in this case? Well, do we know how many times the decreases or increases are happening? No. So that is going to be our variable. So let x represent the number of decreases, number of decreases. Okay? So which means if I have 1 decrease, that means it's just going to be $12 minus 50 cents. If I have 2 decreases here, if that was a 2, then 2 times 50 cents is $1. That means it'd be 12 minus $1. Okay? 3 decreases, 3 times 50 cents, subtract that from 12, and so forth. Okay? Now every time a decrease happens, though, we get an increase in sales. Okay? Now the question is asking us for what? It's asking us for revenue. Okay? And what is revenue? Well, revenue is just how much money you make, right? So revenue would be the cost times sales. Okay? Cost times the number of sales. So our job is to find at what price can we maximize the revenue. So we hear the word maximize again. That means we want, excuse me, a vertex, which means we want to complete the square. Okay, and we're going to do just that. So let's multiply this out. So if I multiply 12 times 36, so that's 360, 72, 422, 432, 432. Okay, and then so we have to first expand this before we can complete the square. I'm going to multiply that out as well. And give me 1 second, then grab a calculator. Okay, sorry about that. Okay, so 12 times 36, yep, perfect. Okay, sorry. Alright, and then if I multiply the 12 by the 2, that'll give me 24x. And then I'll multiply that in, so negative 0.5 times 36 would be negative 18x, and then negative 0.5 times 2, well, half of 2, that's just negative 1x squared. Okay? Now from there, let's rearrange it to get negative 1x squared. And then 24 minus 18, excuse me, plus 6x, and then plus 432. Okay. Now, let's complete the square. So the more you do it, the more you realize that completing the square is actually not that bad. So for example, I'm going to show you how to complete the square in pretty much 2-3 steps. Okay, so I'm going to do a bunch of steps in one shot. So first I'm going to factor out the negative 1 out of here, okay, which means I get x squared, negative 6x. Why is it negative? Because 6 divided by negative 1. And I'm going to leave a bunch of space, okay, and then plus 432. Now, I know that I need to find half of 6. So half of 6 is 3. 3 squared is 9. So I'm just going to put plus 3 squared and then minus 3 squared. Okay. Now, the next step. Well, that's going to be equal to negative 1. And then, I know I'm going to need to copy all of this down. Okay, and I know I'm going to need to free out the negative 3 squared. So let's free out the negative 3 squared first. And I'll show you why in a second. Negative 1 times, negative 3 squared is negative 9, right? Negative 9 times negative 1 is plus 9. And then plus 9 plus 432. Okay. Now, I know I need to factor this. These first 3 terms, right? Okay. So I need 2 numbers that will multiply to give me 9. But at the same time, let's add to give me negative 6. Negative 6, so which means the 2 numbers are going to be negative 3, negative 3, negative 3, negative 3. Which means, what goes in here? X negative 3 squared. Okay? Because this would turn out to be x minus 3 times x minus 3, which is the same thing twice, so x minus 3 squared. Okay? Now, few of you may have noticed that there's been a pattern. And yes, there is a pattern. Once you understand what's happening, that we're essentially factoring these first three terms, there is a trick. The reason I left it at 3 squared and not write down 9 is because you realize that the pattern is this, that this number is always going to be 1. So that means that if you were to write this out as a perfect square, you're taking 3 times 1, which is 3, times 2 is 6. Which means that if I wanted to go from this step to this step, all I need to do is copy down that number, which is a 3, okay, or the square root of 9, which is also half of 6. Okay? And this sign will copy down as well. Okay? And that's no coincidence. So, in fact, if you are watching this far in the video, you realize same thing happened here. Sign, copy down, and square root of 1 squared. Look back here. This first sign was copied down, and what is the square root of 9? 3. And again, up here, sign, the first sign was copied down, square root of 16 is 4. Okay? Now, and there you have it. Okay. Oh, I guess we didn't fully finish this because I needed to add this up in order to get a final answer, which means the final answer is just negative 1 x minus 3 squared plus 441. Okay? So at what price can we maximize her revenue? Well, 3. Well, what does 3 mean? Therefore, we need 3 decreases, 3 decreases, 3 decreases, to get a maximum revenue of $441, to get a max revenue of $441. Okay? But that doesn't answer the question, does it? It's asking what price. Well, if I know it's 3 decreases, 3 decrease of $1.50, okay, so what's 12 minus $1.50? The price should be, price is $10.50. Okay? Awesome. Alright, so here's a bunch of practice questions. Go through them. As always, if you have any questions, please post under math questions. Yeah, anyways, thank you.